Exercise 3, question number 1. The box plots show the distribution of the speed of cars on two motorways. Compare the distribution of the speed on the uh, two motorways. So we want to compare the speeds on two motorways. So this is a box plot. Box plot is main idea is median and the IQR. So we have to focus on median and IQR. Median of A and B motorway. A motorway, we can see that 76. B motorway, it is 72. And IQR, okay, I will stay with like this. Median of Q2, then Q1 is 75 and 65, and Q3 is 80 and 75. So IQR in Q3 minus Q1, this is 80 minus 75, 80 minus 75, 5, and 75 minus 65, which is going to be 10. So I have the table now. So here we can tell that by looking at this one, median of motorway is greater than uh, median of motorway of A is greater than the that that of B by 4. 76 minus 72, 4. So you want to tell that median of A is greater than by median B by 4 kilometer per hour. This is we can tell that Q1 as well. Okay, Q1 of median of then that of B by, that is 10. When you compare 10, and also we can write the Q3 is greater than by 5 kmph minus 1. Median of motorway A is greater than that of B by 4 kmph minus 1. The same thing I am following. Q1 of first quartile of the motorway of A is greater than that of B by 10. So this difference is okay. I write the difference since it is 76 minus 72 equal 4, 70 minus 65 equal 10, 80 minus 75 equal 4. And in contrast, this one, the IQR of motorway I wrote again medium of greater motorway of A is greater than that of B by 4 likewise. Then Q1, Q3 and the spread of motorway B is greater than the spread. We can see that this IQR range is more than this, or spread is more than this. Now, so this is motorway A and this is motorway B. So what you can tell about motorway A? Yes, we can see that when you look at this spread, even this is third quartile and the first quartile started here. It means the motorway has a more speed, or we can say that we can see now this is first piece and second and third piece, and this is the fourth piece of data set. You can see that all 3/4 of data is above the 75 here, and 1/4 is less than 75 in here. 75 up to third quartile is mean 3/4 of below 75. So that is also one observation. You can see that because we make this box plot divided into 4 pieces with the data set. The first one is first quartile, second one is second is median, and the third one third quartile and the end. So basically 4 pieces. So then these 2 pieces we are seeing in here, and we can see that 3 pieces is more than 75. 3 out of 4 data, and here 3 out of 4 data is less than 75. So we can tell that more number of the motorway, the car driving motorway has more speed, overall speed than B. But what do you think that number of cars? Only 10 cars used for this, n equal 10 sample amount, and this is n equal 100. Usually it should not be, then it's bias. If we take 100, then we have to take the 100 data. Then this box process is not going to work, because this is just for 10 data and this is 100 data. So it is not realistic. I mean, yeah, there are situations sometime for a day or within 1 hour. Sometime in some roads you can see only 10 cars at the same time. Other roads 100 cars. So it is realistic. But then when we compare, it's difficult to come to a conclusion. Okay, assume if it is the same data, then yeah, n is 100 and n is 100 cars. Also, likewise, we can get more accurate data if it is n need 100. If we make into n is 1000 and n is 1000, then the data, the box plots are more accurate. So we can use good results. Now we don't know number of cars was there are no more details. So we will leave as it is now. It is depend on our requirements, the objective of the so according to this one, we can see that the objective compare the distribution of the speed on 2 cars. Sometime why it has more speed, maybe less number of cars or less junctions, and this is more urban area and more number of cars. So likewise we can think about different reasons to happen this. So That's how you want to look at a data set. Just not this is greater than this one, this is greater than, no. You want to get the sense out of it. Question number 12. Two classes of a primary school children complete the puzzle. The statistics is given and calculate the mean and the standard deviation. So class 2B, x bar 2B is summation x over n. So this is going to be 650 over 20. And standard deviation of 2B equal summation x over n, summation x over n. This is x square, this is x square. So this value is going to be 32.5 minutes, and this is going to be summation x square is given 22,000 over 20 minus 32.5 square. So sigma 2b is 6.61, and class 2f. So this is x bar 2f is summation x over n, that is 598 divided by 22, which is 27.2 minutes, and standard deviation sigma 2f is the same formula. Then this is 19,100 divided by 22 over 27.2 square. So this is x bar basically. The answer should be around 11.4. When we consider the mean of those two classes, we can see that mean of x bar 2b, right? The mean time of actually, let me do differently. I will delete this one. Class 2b x bar 32 and the sigma, and then we can see that the mean time of class 2f is lower than the mean time of class 2b. Hence, class 2f generally higher Hence, it shows that the class F has more time spread out. That's me. Let me draw the. Usually, the theory is if it is normal distribution, um, if this is x bar, so then x bar plus standard deviation and x bar minus standard deviation, it will cover 68% of data. So then when you look at this one, 27.2, it has a less spread out. It means the data, the peak may be more higher than, okay, let me turn into the green. This is with the green. So this is for F, because more data within an X bar somewhere here. Okay, I will bring the X bar one in different one. So if it is, this is X bar, this is X bar for class F, and it has more spread out. So when you look at the mean, so this is X bar plus sigma, X bar minus sigma, and this is X here, X bar plus sigma and X bar minus sigma. Since this F class, I redraw this graph. So this is for B. B, you can see X bar, and this value is 6.61. The spread out for both sides is 6.61, and here 6.61. So then basically within one day 50% of data, sorry, 68% of data usually within this value is X bar minus 6.61, and this value is going to be 6 bar plus 6.61. But in class F it is 27.2, but this with this far, it means this is going to be X bar plus 11.4, and this is X bar minus 11.4. So this distance is 11.4 both sides. Now you can see that this 68% of data is more spread out. So this is the idea. Further, I calculate this value. X bar is 32.5, and then X bar plus this one 39.1, and this is X bar minus 61 is 25.8.9. So basically if we draw a number line here, so X bar is 32.5, and this is 25.9, and this is 39.11. So this is for B, and 68% data is here. And for F, 27 point is somewhere here, and 15 point here, and 38.6 here. It means 68% of data is in between 15.8 to 30.8. Here 68% of data 25.8 to 39.1. So we can see that F class is overall that it is better than the B class, and however the spread out is more than this one. So I work these things under assumption of they follow normal distributions, because I did discuss, because you may need this idea in the future. I was thinking I'll accelerate a little bit further. So this is 68%. It means if this is symmetric, then this is 34, 34. It means from here to here 34, 34%. And here to here 34%, 34%. And we know that from up to mean it is 50% data. So then 50% plus this 34 up to here, this is 50% and this is 34. That is going to be 84% of data less than 84% of data less than 39.11. So the same as here, 84% of data less than 38.6. If you can't understand this one, just leave it. You may understand in the future other topics. Question number 3, we have a curve, the cumulative frequency diagram, and 80 boys and 80 girls. Compare the height of the girls and the so then we know that this is going to be, you can find mean or standard deviation. Then we have to consider Q1, Q2, Q3. So it means basically Q2 is the median, and then IQR, basically Q3 minus QR. So those are the two tools we have to use. So then 80 data mean, the first quartile, 80 divided by 4, this is going to be 20th term. We need 20th terms of both A and B, that is girls and boys, and then Q2, that is 80 divided by 2, that is 40th term of both, and then Q3 is going to be 80 divided by 4, 60th term of both boys and girls. Now we know that we can find if this is the curve, actually it is increasing curve, and those are the cumulative frequency and variable, and you can find the 20th term. So you have to go 20th and you want to read this value. So that's how you want to do from the graph. So I'm not going to do the graph. So you can see that Q1 for boys is 154.5 and for the girls 149.5, and Q2 for boys 163, and median is 158 for girls, and Q3 171 and 164. This is the median. So we can see that boys median is lower than girls median. Sorry, the girls median is lower than boys median. So from here we can tell that boys are generally taller. So boys are generally taller as median of boys greater than median of girls. Now they spread out. So we'll find IQR boys equal 171 minus 154. 171 minus 154.5, 16.5. And IQR for girls, 164 minus 149.5, that is 15 centimeter. So spread out of boys is higher than the spread of height of boys is greater than the spread out of girls, as IQR of boys greater than IQR of girls. Question number 4. A sample of the daily maximum relative humidity is taken from the large data of Lucas and for Cambon during 2015. The data is given in table, so that so I jot down this one. This is Lucas. There are 15 datas, so I write, instead of 100 I write HH. So first of all, find Q1. So 15 divided by 2, that is 3.75, round up. So round up 4. Fourth term. So first term is going to be 1, 2, 3, 4. It is 100. Fourth term, I think 89, 91. I miss one. 94 and 98. 15 value. Now it is 98. And Q2 is 15 divided by 2, 7.5, round up. So 8 term is 100, and Q3 I don't need to work out actually, still hundreds all. This is going to be 12, 3.7 times 3, 11.25. So round up, which is 12 term. This is 100. And now for Cambon, Q1 equal 15 divided by 2, 3.75. Round up, it's going to be fourth value. Fourth value is going to be 92. And Q2, it follow the same thing, the 8 term. So 8 terms is going to be 98. Here actually Q1 is 98, Q2 equal 100, Q3 equal 100, Q1 equal 92, Q2 is going to be 98 and 8 term, and Q3 is going to be again 12 terms is Q3 100. Now we want median. So we can see median, this is 100 and this is 98. So we can tell that U midi of Lucas is generally higher than the humidity of Cambon, as median of Lucas is higher than the median of Cambon. Now that one, now the spreading. So I want to calculate the IQR of Cambon. So IQR Lucas is 100 minus 98. 100 minus 98 to 8. And IQR Cambon. So this is going to be 100 minus 92. 100 minus 98 is 200 minus 2 is 8. So we can tell that the spread of humidity is higher in Cambon than Lucas, as IQR is higher in Cambon than Lucas.